Good afternoon, everyone, and welcome to Taco Tuesday. This is Rich Medairos, and my partner, Brett Zerba, will be presenting today. I'm actually going to be the master of ceremonies, and Brett is going to be the presenter. So just to go through a couple of housekeeping things, just to make sure that everyone can see Brett's screen. Let me see. I click on, say no one can see your screen. Hold on one second, everyone. Now viewing Brett's screen. Okay. So what we'd like you to do, again, as part of this little housekeeping effort here, is if you could just wave your hand and just click on your little control panel there that you're waving your hand because you can hear me. I can see hands all over the place, and also that you can see Brett's screen. So that looks like we're in good shape. Okay, a couple of other things. During this broadcast, you can ask questions by typing in the questions. And I will stop Brett periodically during his presentation, and we'll pick questions and we'll ask as we go along. We are going to record this broadcast, so after the presentation is complete, you'll be able to download the broadcast. I think it needs like 24 or 48 hours before you can actually access the recording. A couple of other quick things. If you'll notice on your control panel, you should have 3 handouts that are available. One is on the FIFE pump I&O manual. The second one is on the KS pump I&O manual. And the third one is pump startup checklist. So those are 3 PDF documents that you can download. The other thing is that you will be able to download a certificate for your professional development hours. You'll receive an email notice when you can download that certificate. So I'm going to turn it over to Brett. Brett, hopefully you can hear me okay.
Yes, I can, Rich.
So I'm going to turn it over to Brett, and he's going to start the presentation, and hopefully everything will run smooth. Now, just a quick note, we are working in a bit of a handicap situation in that in the world of webinar broadcasting, we are tied to the webinar broadcast service. And apparently there are millions of people all over the planet that are using these different services. So we've got our fingers crossed that the service won't give us any problems, but if we do have some technical difficulties, we'll chime in and let you guys know. So Brett, take it away, as they say.
Thanks a lot, Rich. Appreciate that. Again, my name is Brett Zerba. I work for Taco Comfort Solutions. I'm an applications engineer, and I will be doing most of the presenting this afternoon. Maybe morning, depends where you are. I know we have a wide range of folks attending. As maybe some of you can notice, I learned how to, well, not just spell hello, but write hello with my pen. So hello, everybody. Let's get started. First off, I do appreciate you spending some time with us. Hopefully you get something out of it. But this is really, as the title says, HVAC pump basics, okay? And we really want to try to go over some of the intricacies of HVAC pumps, the pumps that Taco makes on a daily basis and continues to make on a daily basis at our Cranston facility, US facility located in Cranston, Rhode Island. Obviously, there's other HVAC pump manufacturers out there, but this presentation is by us at Taco. And one of the first things I like to mention is we call them pumps, right? Rich and I are more concentrated on the commercial industry, high rises and schools and other types of buildings, bigger buildings. But some of you, if not, many of you possibly could be more on what we consider the residential side or the wholesale side of the business, smaller stuff, homes, right? Hopefully many of us, if not all of us, have a home that we live in. So the residential types. And you folks may be more used to the pump being called a circulator. Okay, well, guess what? They're the same thing. The words are almost synonymous. Pumps or circulators are the same thing. At our facility in Taco, we have one bay. Well, I'm going to say one bay. Sometimes it stretches into two, 1.5 that makes circulators. And then in another bay, we have a bay that makes pumps. But believe it or not, the components for the most part are the same, right? The main components. So just keep that in mind. So let me see if I can figure out how to delete that. Hello, erase all. I did it. Wow, I'm pretty proud of myself.
Wow, that's impressive, Brett.
Thank you, Rich. Well, I had a good teacher. All right, let's get started. So when we start talking about centrifugal pumps, right? That's another word in our industry, centrifugal, right? And hopefully some of you know what that means, right? They move around or the components. There's not a Rich taught me this a few months ago, or maybe a year ago. Now things kind of blend in. That there aren't a lot of moving components in a pump, right? You have a shaft and an impeller for the most part, but they do rotate. But the main function of a pump is to create a differential pressure, a delta P. In our industry, in our HVAC industry, if you're an engineer type or a contractor, you worry about delta P and head loss and stuff like that, pressure loss, okay? But that's what a pump creates internally. And inside the pump and out in the world, out in the pumping world, in the system, water flows from higher pressure to lower pressure. Okay, so water flows from the higher pressure to the lower pressure. And I'm going to show you some cutaways to get so you can understand or get an understanding of what's going on inside the pump from a higher pressure to a lower pressure environment. The delta P that is produced by the pump. All right, so this pump is producing delta P. It's built into a system. I don't care if it's in your house. I don't care if it's at the school that you used to attend or at the other businesses out there in the world. That delta P has to overcome the resistance in the system, and we'll talk about that. So that delta P induces flow against that resistance, and we'll talk about that, and I'll show you
So
a couple
Brett, before we go, Brett,
Yeah.
can you hear me okay?
Yes, I can, Rich.
Before we have a quick housekeeping item.
Yeah.
We are aware that some folks are having difficulty signing on. We do have someone working on that, and we hope that they can get it resolved very shortly. But I have gotten several questions, Brett, or actually comments saying that we can't seem to sign on. So just to let everyone know, we do have someone working on that, and hopefully we'll get that sorted out pretty soon. I think we have almost 500 people attending right now, so we'll see how they fix it. And if for some reason we're not able to have more people attend, then we'll figure out whether or not we need to rebroadcast this in the future. But in the meantime, Brett, take it away. Just wanted everybody to know that we are aware that there is an issue out there.
Thanks, Rich. Appreciate that. We had quite a few registrars. Well, anyways, let me get back to my presentation. So again, the delta P that the pump, right? This mechanical piece of equipment induces internally it flows against the system resistance. The next bullet point there talks about an open system. In the commercial world, most HVAC pumps go in closed systems, and I'm going to explain the differences between those and show you some drawings against those. But this is an important point when Rich and I are talking with folks, be it in front of folks or one-on-ones or whatever. In an open system, these are systems that are open to the atmosphere. Think about a condenser water system or a cooling tower or something like that. The delta P also induces lift against the atmospheric pressure and gravity. In a closed system, it does not. So when I refer to a closed system, maybe inside an apartment complex, right? You have a boiler down in the basement, as an example, or in the first floor, whatever. And there's a 6-story, 10-story building, and so you have to get hot water all the way up to my grandmother, who lives on the 8th floor, and your grandmother lives on the 6th floor. Well, that water goes all the way up and all the way down, and the pump does not have to overcome that pressure of the vertical height. Now, it does have to come over system resistance, but I'll talk about that a little more. So please, there is a distinction there from a calculation standpoint. Rich will be doing a presentation on how to figure out system resistance, and we have some software that does that, and we'll show you that down the road too at other webinars. But nonetheless, in a closed system, the pump does not have to overcome that vertical change. So just keep that in mind. That is something that, you know, when we talk basics, that's an important fact to remember. Let me move on here. So closed systems, right? Not open to atmosphere, right? The delta P that the pump induces flow against, system resistance. So system resistance is pipe. As water moves through pipe, there's resistance, okay, within that pipe. It doesn't matter the diameter. There's probably ways to size the right diameters, but there's resistance in there. Every time that you turn a corner, right, with an elbow, that's more resistance. So the pump has to overcome that. You go through a piece of equipment, you go through a valve, that's all resistance. That's the delta P that this pump has to overcome when you start doing calculations. No lift in a closed system. And here's an example of a closed system, right? Rich, I love that dot you showed me, so I'm going to try it. Can you see my dot, Rich? Or the
Yeah,
dot?
I can.
Awesome.
You know,
See how
now
big
that I
it is?
see it in the presentation mode, the dot is huge. It's like the
I
size of a
know.
dot.
Isn't that great? So here, Rich and I have been doing a lot of go-to meetings and webinars recently. So we are getting a little stir crazy, and we get excited when little things, we notice little improvements, or we think they're improvements anyways. So here's a closed system. What do I mean by that? Well, here's a water-cooled chiller, right? It could be a boiler, same thing, but it's the water is internal and it's not open to the atmosphere, right? There's no pressure coming anyplace else. Here's our little pump, I should have made it bigger, right? Because that's the main focus of this presentation. And then there's some piping and there's some valving over here and some fan coils I happen to represent, some other pieces of equipment that Rich and I have talked about, air and dirt separators, expansion tanks. So the water is internal to this system. So I don't care if these fan coils are on the 6th floor, 10th floor, whatever. It doesn't, the height, the length to get to them matters, but the height does not. So that's a closed system. All right, Rich.
So
Now
one of the things that we want to point out is that, as Brett just mentioned, it is a closed system and the pump is overcoming the resistance of all the components that Brett outlined. However, the components at the lowest part of the system do see the static pressure for rating purposes. In other words, if the building was tall enough, let's say that the building happened to be 231 feet tall, just coincidentally, that would be about 100 pounds per square inch. So the equipment would be subjected to a static pressure of 100 pounds, but the pump doesn't have to overcome the static for moving the fluid through the system.
that's a great point. So that means the equipment has to be sized and selected correctly from a pressure rating, but we still don't have to overcome the height, the pump size in itself. Thank you, Rich. That was great. So here's some open system discussions, right? Open to the atmosphere, and I'll show you another picture. The delta P that the pump produces does not, again, has to overcome the system resistance, the flow against the head, right? The piping and everything else, and the lift or elevation change. It's not coming back, right? It's not coming back. So keep that in mind. And here's the example, this cooling tower, I'm representing a cooling tower. Many of you hopefully know what that piece of equipment is. It's open to the atmosphere, okay? So the pressure here, so this pump actually has to push the water up, and we have to take that vertical height into account, as well as the losses in the pipe. This pump over here is still in in a closed loop system, so it's only rotating around the water there. So keep that in mind when we talk about pumps, or when you start thinking about sizing pumps in some of the calculation classes that you may be attending down the road. So one little definition there. Here's a little pump components and principal operations. I apologize, it's a little blurry here, but I have a different sketch coming. So this is I can tell it's a cutaway of a base mounted pump. And maybe some of you, I like this little dot. I'm gonna get it again here. So here's the feet of the pump. I didn't even label those, but here's a cutaway of the pump. And one of the most important parts of a pump, the moving component, is this impeller. So this is the suction. So the water would go right into this hole here in the impeller, right? And that's the impeller. So this all makes up the components of the impeller here. And these bad boys here are vanes. And I believe, if I counted correctly, there's 8 vanes on this particular impeller. The design engineers, our R&D engineers, would design for different size pumps, different types of pumps, different types of vanes, okay, and different quantity of vanes. But nonetheless, a vane is a very, very important part of an impeller. And there's different types of impellers. I'm going to focus on closed impellers. That means that there's a shrouding on both sides of the vanes, okay? They're not open. Some impellers on smaller circulators, and my good friend John Barba and his team will give you some more information on circulators and their components, but they may have open impellers. But for our conversations in the commercial world, because of the sizes and whatnot, they're all enclosed, okay, from that regard. And the other important distinction I like to talk to, and some of you may have been to my presentations about this before, the impeller the vanes do not scoop water, they throw water. So this rotation would be in this direction. Okay, see how the vane's curved a little bit? It actually throws the water out. It doesn't scoop the water. So just keep that in mind. Then this is a cut water, and we're going to go over what that means in another slide. This is the volute casing. This is the volute casing. Suction again, impeller, diffuser throat. This just means kind of the discharge, and this is the discharge. And most pumps, if not all, are flanged on both sides, okay? So just keep that in mind. So that's a little cutaway of some of the components within a pump. Here's a little cleaner package here, a print. So the impeller the impeller spin accelerates the liquid radially. So this is the lowest point at the suction, right? It spins in this direction. Liquid is forced outside of the impeller, so it's thrown out here as it's going in, and it discharges this way out the discharge. Cut water diverts liquid. That's the cut water right here, this cut water piece. So this is a very important part of the design. The R&D engineers or pump design engineers really are very concerned about the location of that and how close the impeller can get to it. The closer, the less internal losses of liquid, right? The water doesn't spin around in here, and the less internal losses, the higher the efficiency of the pump. So this particular picture is representing a full trim impeller, okay? So that means there's very, very little space between the cut water and these clearances here. You do have to have some clearance. You can't, it is a moving part, so you don't want any rubbing there, obviously. The impeller eye, that's another term, right? The impeller eye, suction, impeller eye. A lot of these terms are, they mean the same thing. So if you hear different things at different times, nonetheless, they can be kind of the same. That is the lowest point, lowest pressure inside of a pump. So keep that in mind. And then when engineers design pumps, and we start manufacturing and testing these products, they will have the maximum impeller cut, and we'll get into that when I show curves. And then there's a minimum impeller cut, and it's really based on the hub of this the support around the suction in the eye of the impeller. So you have a maximum impeller and a minimum impeller, and that impeller can be trimmed anywhere in between. And so many of you may be involved with purchasing pumps, and you'll see on the pump tag or something the impeller trim, right? So most pumps at some point the impeller is going to be trimmed, and at Taco we actually balance these impellers as well. If any of you have ever been bought new tires and they balance your tires, right, to make sure they spin the proper way, they actually add weight to them, right? I think it's a piece of lead they put in certain spots. At our facility, our balancing machine actually takes some weight off of these impellers. And there's actually a guide put out by the Hydraulic Institute of the actual spin rate in the requirements there. But nonetheless, they're all balanced before they leave our facility. So keep that in mind. And trimmed and or balanced depends on the actual specific order. How we doing, Rich? We still there?
Yeah,
Oh,
I think we're doing really good. Actually, had a couple of quick questions pop up.
Yeah.
If you have a second. So we have one question that says, why only one expansion tank allowed per system? Do you want to try that one, Brett?
Although this isn't really the focus of this presentation, but the answer to that is that you can put in as many as you want.
That's correct. You can have as many expansion tanks as you want, but they all have to be connected in some kind of manifold arrangement so that they have one connection to the system. So you can have multiple tanks, but only one connection. And then that connection needs to be at the suction side of the pump in order for the pump to operate properly.
I believe if you go to the TACO website, I'm pretty sure we already did a webinar on expansion tanks, and Rich really got into a lot of detail. But didn't we already do that one, Rich? I think we did. I'm so confused now.
I think so, yeah. So
yeah. It was
I
well
think the
attended,
question really was in context to proper pump operation. So
oh, okay. Yep. Yeah, okay. Anything else, or should I move on?
Yeah, why don't you move ahead? There's a couple of other questions out there, but I'll wait till we get another point. We can stop and go through some things.
In the pumping world, centrifugal frame-mounted end suction pump world, there's a couple of different discharge arrangements. Centerline or tangential. So hopefully the two words kind of tell you which one's which, right? This is a centerline discharge. This is a tangential. It's kind of tangential. They both, these pumps here probably still give you the same flow and head. It's just a different arrangement of different types of manufacturers, okay? The centerline is weight evenly distributed amongst it, and centerline is self-venting. So maybe one has a little positives over another, and maybe the other has positives over the other. But just so you're familiar with both types of mechanical arrangements there. And all of TACO end suction pumps are centerline discharge. So just keep that in mind. And I didn't want to spend a lot of time on this, but I do like to at least show you different types of discharge arrangements. So just keep that in mind. Here's some centrifugal pump components, okay? And just so you get used to the terminology, and we've been talking about some of them already. This is a base-mounted pump. Well, how can I tell that, or how can you tell that? Here's the base. So I think that's probably its first clue, right? You'll hear the talk about base-mounted pumps, okay? And then this is the wet end. We call it the wet end, or the casing end, or whatever, the suction and discharge. Okay, so that's the cutaway. That's the external part of the cutaway that we just looked at earlier. Here's the suction. Notice it's not uncommon for pump manufacturers to have a little straightening vein in there. It does not replace, it helps proper water flow into the pump, but it does not replace a suction diffuser, as an example, or 5-10 diameters of pipe to straighten the flow. One thing pumps, HVAC pumps really like is laminar flow, right? We don't like swirling around. Pumps pumps have big issues when they get swirling around. So the water needs to come in with a lot of straightening components in front, or a suction diffuser. That's a piece of trim. Some of you are familiar with trim. It's just a component that all of us pump manufacturers offer to the industry. So it would bolt right up here, and it has veins in it, so the water goes in straight. Here's a drain pan, not uncommon, right? So I mean, not that it should happen, but every once in a while there might be some dripping from the seal or loose connection. So this just connects, can pick up that stuff here. This base is pretty heavy duty. Discharge, casing and volute, right? Different words that mean the same thing. Bearing frame, we're going to look at that. This is a bearing frame here, pretty common component. Motor, here's a motor component here. And then there's a coupler, and I'm going to show you some breakdowns of the coupler with a coupler guard here as well. I'm going to talk about installation a little bit, but please review those I&O manuals in the checklist, that the attachments that are here, because it really goes into the balancing, not the balancing, but the alignment, proper alignment of these bases. Us HVAC pump manufacturers, if you look at an I&O manual, the first time you read it, you get scared about how many times you're supposed to align these couplers, and we're going to look at that in greater detail. And technically, you're supposed to grout these bases, all right? You're supposed to grout these, and there's a whole procedure in the attachment about how you do that. In essence, what it means is to fill this up. Once it's mounted and aligned and leveled, right? You got to follow the I&O manuals and shim this up and level it properly with the proper equipment. This base, this cavity, right? There's actually a cavity in here, open space, should be filled with grouting, which is a type of concrete that makes that base solid. So it really takes away vibration and whatnot. Most of us pump many bases on smaller motor pumps. I have seen installed properly, aligned properly, and run fine without grouting. But if you ever call your manufacturer's rep or Taco or any other pump manufacturer, one of the first things they're going to ask if there's an issue with the pump, is it grouted? So I just keep that in mind. Please make sure, if you're on the installation end, or you are a person that goes checks these and there's issues or whatever, just reread those I&O manuals, and you'll get a lot out of them in that regard.
So Brett, we have a couple of quick questions. They actually refer back to, you had that picture of the centerline discharge pump and the tangential discharge pump. If you could go back to that. And the question that popped up is, what is self-venting? What do you mean by self-venting? And so you said that the centerline was self-venting?
Yep. It means that the air, because there's air induced in here during startup, the air is able to, it doesn't get entrained and stay within the casing. It actually comes out and goes into the water. So it's not vented per se. It can be vented, but it's vented out of the casing itself. It's vented out of the casing itself.
Okay, and the other question along the same lines of those two pumps, it says, are the two pumps the same efficiency?
More than likely, they're within 1% or 2% of each other. It all depends on each manufacturer's. There's other impeller design criteria that's taken into account, smoothness of the pieces of equipment and stuff like that. So yes.
Okay, and then last question on this series. Let's see. The question was, it actually went back to your cooling tower thing. It says, let's see, when it comes to, here it is. In an open system, specifically open cooling tower, the example you showed, wouldn't you gain back at least a portion of the gravity loss on the return? And I think what they're getting at, and I think what you implied, was that the static height difference is the difference in the open portion of the cooling tower. So if the cooling tower is 12 feet, then that's the static height difference that the pump has to overcome. In other words, where the water enters the cooling tower it might be 12 feet higher to where the
Where it sucks
water
out.
leaves
Yeah.
the cooling tower.
Correct.
Right, and not the
Right.
piping that goes from the pump, from the, in this case, the chiller, the vertical distance all the way up to the tower. It's only the difference in the tower.
Correct.
Okay,
All right.
and that should do it. We'll look at a few more questions in another couple of minutes.
Super. So one thing about a base mounted pump like this with a coupler and a bearing frame is it's another term that we're going to talk about a little more is split coupled. Okay, that means that the impeller shaft, there's an actual shaft that ties into the impeller that also rotates, is not the motor shaft. So it's coupled in between. And here's kind of a breakdown of what that looks like. Okay, so here's your wet end, right? Here's your casing. Here's your impeller. Here's kind of a cutaway, gives you some kind of more information, more details of what the impeller looks like. Here's a seal, mechanical seal here. One of the main components, one of the main maintenance components of a HVAC pump, especially if it's a dirty system. These seals really don't like dirt, or we don't like air getting in there or whatnot. We can have another presentation about seals and whatnot, but this is the bearing frame. But here's your Woods Duraflex coupler. So this is the coupler, and the two shafts actually mate in there, and that mounts the pieces of equipment together. So here's your pump shaft. So that shaft would go all the way through this bearing frame, and you can see that it's hard to see, but it does tie, the impeller itself ties right onto that shaft. And here's your motor shaft here, sticking in. Obviously the motor generates power, and that's what rotates as well, and that power has to get all the way to the pump. So this is a pretty standard piece of equipment, the Woods Duraflex coupler in our industry. These seals, for the most part, are type 21 John Crane seals. But other people may offer other types, and there's other types out there. But nonetheless, that's kind of a good cutaway in that regard. The Takeo for the FI models, the standard product, there's bearing in here, all right, that keeps the shaft aligned properly. The bearings in an FI model are sealed for life. They do not require lubrication. And if you look on the I&O manual that's attached here, it gives you a whole breakdown of how to properly, if there's lubricated required bearings in there, to get lubrication to them. But so our old FE pumps, and some people actually still want bearing frames. We still sell them with bearings that require lubrication, but nonetheless, these do not require it. We actually have what we call a Fushida seal here, so that protects from contaminants getting into this housing to ruin that. So just keep that in mind in that regard. So let's see what else on this screen. I think that's pretty much it. So that's kind of a good breakdown of the components, the major components on there. Obviously the base isn't here or anything like that. And again, this is the the impeller. You can see the vanes here and a little space in there, and each impeller for each size and model would have a different type of, I mean, they're very, very similar, but they could be dimensionally a little different width-wise or whatnot for the impellers as you go from model to model. Here's a little more kind of a breakdown of the Woods Duraflex coupler. Takeo standardized on these over 10 years ago, and they work very, very well the way they're manufactured with variable speed pumping applications. And in our industry now, upwards of 80–90%, well, whatever, it's a very, very, very high percentage, especially on new jobs, if not old ones as well, have been retrofitted, have a variable speed component that speeds the pump up and slows it down based on other criteria or pressures or whatever, temperature and whatnot. But these work very, very well with them. This guy, I just like to show this. This is the old style coupler. So if you happen to be in mechanical rooms that that you may be on a walkthrough or whatever, old type of jobs, you may see some couplers like this. This is the old what I call tooth style. You can probably tell why we would call that that. That would sit right in here. Let me get my little big spotlight back. So these teeth sit right in here. And once you start putting variable speed on here, and that speeds up and slows down, this material would actually disintegrate or whatever, and you'd see it on the bottom of your base. And we had all kinds of issues. So, I like to at least show you this to make you aware of it, because you possibly may see it on a project or on a walkthrough on a building. So at least you have some idea what the old style coupler would look like. Rich, can you see how quick I'm getting back from my dots to without? Man, you taught me great. Thank you very much.
I know, this is amazing. A couple of quick questions, which I think you can answer real quickly, is would centrifugal pumps be used in a closed loop system or an open loop system?
Great question. I appreciate you bringing that up, but they can be used in both. They can be used in both.
Absolutely. They're used
and
ever
they
since the
are on a
beginning of
daily
time.
basis, right, Rich? We
Yeah.
size them and select them and help folks with designs on them on a daily basis for both types of system.
Okay, let's see. Another one came up here. Let's actually, somebody asked the question, which said, would we be doing a seminar in the future on packing glands? And the answer to that is that we no longer provide pumps with packing glands. Our pumps have mechanical seals. So the answer is no, we won't be showing packing glands in the future. Okay, Brett, take it away.
All right, my friend. Thank you, Rich. Great questions. The more the merrier. Let's see, where are we going from here? All right, so here's the end suction pumps, and these continue to be the most popular style, especially in the US, okay, in the United States. North of the border, for any of my friends, north of the border, probably not, and we'll talk about that in a second, but these continue to be the most popular style in the US, in really an end suction. As it says here, the suction and discharge, I think you can see that by looking, are at a 90-degree angle, right? And suction. So this is base mounted split coupled, like I was talking before. So there's a way to, without the motor shaft is not the impeller shaft. That's the difference between, and it doesn't matter what type of centrifugal pump we're talking about, horizontal, inline, base mounted, whatever, vertical, excuse me. I need a sip of water. Bear with me. So split coupled really represents the motor shaft and pump shaft are separate, are split. So actually on a pump like this, you can change, you have access to the seal, because sooner or later you're going to have to access these seals to change them. You can access this seal without moving this component, without moving.
I think we lost your audio. Let's take a half a step back and do a quick audio check.
Okay, test. Am I back?
Yep, you're back.
Am I back?
You're back
okay.
Now.
All right.
Let's keep going for a second.
Yep.
But well, let's try answering a couple of quick questions that popped up.
Yep.
Let's see. I thought this was a neat question. Let's see. What is not this? Let's see. I just saw that. Nope. This question still. Well, I'm going to have to pass on. I was reading,
Okay.
but it jumped off the screen here.
Yep.
Okay, I know what it is. So the question that came up is they use the close coupled pumps.
Yep.
One of our customers uses a close coupled pump, and
Yep.
it takes up less physical space in the mechanical room. So why would we want to go to a base mounted pump? And I think the main reason that you find yourself moving toward a base mounted pump is physical size. I think we're limited to how big we can make a close coupled pump. Is that correct, Brett?
Yes. Physical size on the motor horsepower as well as maintenance. I would actually direct the answer more to maintenance. Us pump manufacturers, this is a JM type motor. we could make this type of pump that, can you hear me pretty good, Rich? Am I back to normal?
Yeah, it's
Okay,
actually
good.
you're back to normal audio.
Well, some people think I am never normal, but that's another whole conversation. But anyways, uh, a closed couple pump, yes, it takes up less room, but us pump manufacturers can offer these up to 60 horsepower. Um, from a maintenance standpoint, we recommend maybe once you get above, people have different numbers because of the weight of the motor, 10, 15, 20 horse to go to a base mounted. Yes, it's going to take up more room, but you think about the maintenance person down the road that has to access the seal. So you think about this, off the top of my head, I don't know motor weights, but they get heavy quick, right? A small 5 horse, 7 horse, 10 horse, 7.5, 10 horse motor, one person, maybe a little helper, can access this pump and seal it. Otherwise, you're going to need some type of lift up above here to pull that out. I don't care if you're the strongest person in the world. Once these get too heavy, you're not going to be able, with the clearances involved, to access this without some type of chain fall. So great question. And yes, they take up less room. They fit very nice. They fit on bases or for booster systems or whatnot. But really, I think for most bigger projects, you see mostly base mounted specified. Rich, I know you were on the specification side of the business for a long time. I'm assuming that you specified mostly base mounted pumps when you were doing a lot of your work.
Yeah, that's true. I mean, I personally like the base mounted pumps. I have nothing against the close coupled, but the base mounted just wind up being a little bit easier to service. Once you take the shroud and expose the coupling, you could just unbolt the coupling, and now you can service the pump and leave the motor where it is. So makes it a lot easier to service. And that's one of the, like you said, Brett, that's one of the major reasons that people do that.
And I think a lot of us. I am a degreed mechanical engineer. I've been out of school almost 30 years now. Holy moly! And that was college. But anyways, what was I going to say? As an engineer, one of the first persons that brought me under his wing told me, you got to think about the whole project. And really, the maintenance side of it is a very important part of it as well. So I think that discussion's something that we should consider from an engineering standpoint. Anything else, Rich, or should I move on?
Yeah, why don't we move on? I would say I want folks to realize that we do get quite a few questions during these presentations, and we do collect the questions and we do respond to those questions in email if we don't answer them live during the broadcast. So please be aware that whatever you have given us for question, we will provide a written answer for. So don't think. We try to pick questions that tend to repeat themselves during the presentation. So we will be answering the questions.
Thanks,
Back to
Rich.
you, Brett.
Yep. So here's another very common style of, they're called inline. They may be called other types or whatnot, but these are inline pumps. So the piping is these fit inline to the pump. My friends north of the border, probably 80 or 90% of Canada is vertical pumps. It's amazing how they've relied on that. And I'm going to talk about different applications for pumps on another slide. So just bear with me on that. But these are inline pumps, split or close coupled, right? I've been hitting home that terminology. For the vertical KV, KS pumps, these are our models, our designations. If you look closely here, there's actually an aluminum coupler, and that allows you to access the impeller and the seal without moving that motor. This guy here, again, it goes up to 60 horse. These motors get big very quickly, but you would have to take that whole motor out to access it. So some people love these pumps. One of the main reasons I like to talk about these and try to have people at least consider them, and it could be a big change for your office in that regard. Don't get me wrong, I understand that, but is because there are no alignment field. There's very, very little field alignment issues with these pumps. These pumps are aligned when they're installed. It would take a lot to get these out of alignment. The base mounted pumps, if you read the I&O manuals that us and other manufacturers send out, they really need to be aligned very quick. And we can have we have videos that show people how to align those properly. But these guys do not require any alignment. So here's a reason to consider it in your engineering office if you've had some issues on projects for whatever reason, right? I mean, there could be a whole handful of different reasons why there's pumping issues or pump installation issues, and alignment could be a big part of it. Well, if you start specifying these instead, that could go away. But from a flow and head standpoint, a lot of this are very similar to the base mounted in that regard, and I'll show you some ranges. Actually, these go up a little higher, quite a bit higher than the base mounted. These are little horizontal inlines, so they're made for horizontal inline piping. These kind of, we call them vertical because the motor goes vertical, horizontal because the motor goes horizontal. This is a direct coupled again. This happens to be our 1900 model. This is a split couple. This is our K 1600 model, and there's different sizes for those. Probably, a couple hundred to 300 GPM ranges. You'll see a kind of breakdown on that. One thing on these two horizontal inlines, I don't know how many mechanical rooms I've been in, and I'll see a strap on these. Actually, I did not provide a installation manual for these guys, but it's written in there. If you ever see a hanger on these motors, either cut it or go loosen it, because what happens is these are designed to be straight out. They do not need any support. So just keep that in mind. These motors they don't get that heavy. Most of them are probably a couple of horse, 5 horse or less. I mean, there's a couple bigger ones, but they're designed to be self-supporting. So if you put a strap on that, you're going to cause trouble for yourself. So just keep that in mind. So really, they're differentiated by shaft orientation. And then we have the split case. I call them common styles. It's in the category, but these are split case pumps. Really, the old war horses. Some people still specify them. There's some markets in the United States and probably outside of the U.S. as well. And they're probably, for the most part, bigger, although they do get down smaller. But when we say split case, allows access to impeller seals without moving motor or disturbing pipers. So piping. So this is a horizontal one, and this is a vertical one. And then you can actually get these at 90-degree angles as well. It just takes a lot of bolts off to get these in and double suctions, but nonetheless, they're available. And then there's also vertical line shaft turbines, and we will have a webinar down the road specifically to turbines. We have a turbine company headquarters in Nashville, Tennessee. So Taco turbines are now available for the AC, probably more for cooling tower or sump applications, but nonetheless, those are vertical turbines and a cutaway there, multi-stage types and whatnot. Here's a breakdown of the capacities, a general range of capacities, right? So I talked about the horizontal inlines, right? Pretty small flow rates up to 240. I mean, many school systems, this is the range that you might see in there. And then the head loss doesn't get too big. And then, I think we do have some that go a little higher in horsepower, but nonetheless, kind of the range for those. End suction, FICI series, right? That's probably the big range here, 40 to 4,000, right? You can see the head loss here gets up pretty high as well. There's your horsepower. So all of these pumps would be required now by TACO to meet the DOE requirements, the new DOE requirements that the United States has come out with. And that's another whole presentation. kV, KS pumps, your inlines, and you can see here they get up even bigger. So we get this question, Rich and I and others at Taco and other pump manufacturers get this question a lot about these types of pumps. Which application is better for which? And invariably, one of the first things we tell them, obviously size has something to do with it, but one of the first things we tell people is it's user choice, right, Rich? I don't know how many times we've answered that question that way in that regard. It's really what you're familiar with. Like I said, up in Canada, they specify these on a regular basis. Probably 80+% of the market is verticals. In the United States, it may be reversed. It's might getting a little closer now, but as far as chilled water, hot water, any type of applications for any types, they both are almost interchangeable in that regard. It's really what your office, to be quite honest, I tell people, you know why you still specify a certain type? Because that's the detail you have in your drawings. And so when you go to the copy and paste, that's the detail you have, and you don't have the other detail. I'm being a little goofy here, but it's getting late in the day. So nonetheless, you can kind of see the ranges here. The split case pumps go even bigger. You can see that. There's different categories for these, but nonetheless, they get even bigger and bigger in that regard. And some folks are very, very comfortable with these, and they continue to specify them, and we continue to manufacture them. So just keep that in mind. And here's the ranges on those vertical turbines. A couple of the markets for Taco turbines now are mining or farming or agricultural. So it's not just HVAC. The ones we're more focused on out of Cranston would be the HVAC ones. So just keep that in mind. I'm winding down. I do want to show a couple more things. Hopefully we'll have times for a couple questions. The affinity loss, okay? Hopefully you can get a chart on this very, very easily. It's not part of the handouts, but there is a relationship. The pump affinity laws, there's a relationships between flow, head, horsepower, RPM, and impeller, okay? So as things change, you can calculate new numbers, and that's how we do that within the curve. So on the left side, as the RPM changes, you can get a different flow, right? Q is flow, H is head, BHP is brake horsepower or horsepower, and RPM is speed. So if you know different speeds, you can calculate a different flow. The head loss changes by the square. The horsepower changes by the cube. So keep that in mind. And then so you can have speed changes, or normally or in the old days impeller changes, and then the relationship is kind of the same. Right? Head loss is squared and horsepower is cubed. So these are the affinity laws. We on pump curves and calculating impeller cuts. These are used quite a bit, but I don't know how much you guys would need to get into it, but it is important to be aware of them in that regard. So I do want to touch upon pump curves as we're winding down here. Pumps can operate on their curves, right? And here's a simple impeller curve. So each one of these impeller curves are a different cut, right? An inch, and then I show an 11 and 12. So the flow and head the pump can only one of these. And then to get anywhere within these curves,
Hey, Brett, we're having a problem with your audio is cutting in and out. Maybe why don't we answer a couple of quick questions here? Maybe your microphone needs to cool down. But you actually did answer this question. So the person said, if the flow and head is the same, would you use a end suction pump or an inline? And actually you answered that. But let me add one other thing, and that has a lot to do with the physical layout of the pump and how much floor space it takes up. So it may be possible to choose an end suction pump over an inline because of a different piping arrangement or the amount of space that the pump may physically take up. So a lot of times people will select one model configuration over another if they have the same flow and head, strictly based on the amount of space that they take up. Another question that popped up is that, let's see, horizontal inline should not be mounted with the motor. Oh, the question is, if you have a horizontal inline, can you mount it with the motor vertically? I thought that was an interesting question.
It depends on the model and whatnot. Most of us recommend it to go keep the motor mounted horizontally. There are other requirements involved. So personally, I would recommend it going horizontal.
I think in some of our installation manuals, it actually gives some guidance for certain size pumps as to whether they can, if it's a horizontal inline, whether it can be mounted vertically. So we do have some guidance in there.
Yep.
Okay, Brett, take it away. Go back and we'll see what happens next.
All right, we're winding down anyways. So here's the impeller curves. And one thing you need from a basic standpoint is pumps can only operate on its curve. System curve is, and Rich and I have done webinars, mostly Rich, about curves and much more details. So keep that in mind. But every pump system also has a system curve. And this is a calculated curve. And there is your flow in head. That's kind of a part of the affinity laws. So flow equals head squared. So this is actually a calculated component based on your design point. So every pump within a system has a system curve associated with it. You may not even be aware of that or whatnot, but you do, from a basic standpoint, need to understand that there are system curves once a pump's installed. And there's also horsepower curves on these pump curves. And I'm going to show you all of them together, except the pump curve, the system curve. This is a parabola. So if you remember back to when you were in algebra, was it algebra we learned about parabolas? Whatever, it's been a long time. And your friend that had trouble with parabolas would say, when am I ever going to need to know something like that? Well, today's a day you need to know something like that. There's a parabola, and it was calculated by that calculation I showed you. So here's kind of a breakdown of a pump operates where system and impeller curves intersect. And again, this is very basic information, right? That's what this presentation was about. Rich went into a much more detail on other presentations on curves, so I'm not going to spend too much time on that. But here's some general information that you can expect. It's not unusual when you select a pump to see the system curve and the actual impeller curve shown, but then the family of curve is there. And then, on the left-hand side, you see the head, and this is common. And on the bottom, you see the flow in GPMs. And here's really, notice how I figured this out too, Rich. Here's how you can zoom. Here's kind of a system, a curve, and there's your affinity lines here, your horsepower lines, and there's a whole bunch of details and a whole big presentation on all that. But it's good to get familiar with some of this information, just so you're familiar with it. This is your system curve here. This represents the design point. That's the actual impeller point there. So keep that in mind. And again, here's your different impeller cuts. More than likely, to calculate this one, the pump manufacturer used the affinity laws to get to that point based on the flow and head. You could do the same thing if you want to practice. And then there's your head down here. And May 12th, we have a seminar and MPSH. Rich does a great job on that. So May 12th, a webinar. We wish it was a seminar, but in that regard. And here's some other information you could expect to see on a curve as you go, or a pump curve for a particular pump in that regard. So again, I did want to at least advertise that this was for basic pump information, just to get the information out there, to take away some of the stuff that maybe we don't know or we take for granted or whatnot. So just keep that in mind. So other than that, Rich, I'm going to turn it back to you, and let's see if we can get through a question or two before we close it up.
Yeah, we have a couple that popped up. One, should we consider NPSH in choosing one style pump over another?
Whenever you go to a pump curve, the MPSH is shown, and I would have to look at it each application to see if the MPSH is less for your horizontal or base mounted compared to your vertical. But yes, you should consider MPSH when you start looking at that.
Yeah, and let me echo what Brett just said. It is dependent on the actual design operating point. You may find that one pump configuration has a better NPSH profile than another, but it winds up being operating point specific. So it depends on
Rich,
the actual configuration of the system.
Rich, I don't
Go
think
ahead.
there's Rich, can you hear me?
Yes, I
Hello?
can. Go ahead.
Yeah, I don't think there's a general statement that you can say the vertical type of pump has higher or lower MPSH than the horizontal for the same design flow and head. I've never heard that statement. That could be out there, and I apologize if it is. But have you heard that, Rich?
No, that's the issue. The issue is it becomes, pump specific and more directly has to do with the design operating point.
Yeah.
Yeah, you have to look at those things very carefully. Okay, we do, as I mentioned earlier in the presentation, we received quite a few questions, and we're very, very pleased that folks had generated these questions. We will answer those over the next few days. We collect all the questions, we get it into a spreadsheet format, and Brett and I go through and answer every single one. So if we did not answer your question online during the presentation, we will be getting to your questions in the future. So with that, Brett, do you have a few final words you'd like to say before I wrap things up here?
Yes, I do. I do appreciate everyone's attention to this. Hopefully you got something out of it. Obviously, TACO is a pump manufacturer, so it's important to get the information out to folks like yourself. Great questions. We appreciate the questions. Any questions, a good question. Thank you very much. And please stay there. Wherever you are, United States, outside the U.S., North America, wherever. I know some folks are outside the U.S. Hopefully, you're all safe there as well. Signing off. Take it away, Rich. Thank you.
Thanks, Brett, for a terrific presentation. Folks are chiming in here saying thanks also. We want to just say a few words and say, again, thank you, everyone, for participating in today's webinar. We're extremely pleased that we've had so much interest in these TACO Tuesdays. Final words from the entire TACO team is to please be safe out there. Look for on our website the schedule for the TACO Tuesdays that are coming up soon. So with that, I'm going to say this is Rich Medairos and Brett Zerba on behalf of TACO and the entire TACO family of companies. Express our great appreciation and be safe out there. I'm signing off.